Hi everyone, Mr. Skelton here, back at it. Lesson 6, Unit 6. Today's lesson is going to be challenging, just to give you a heads up here. So at any point in time, if you need to pause, rewind, and think about what we're doing, please do that. I'm going to try to go as quick as I can, but also be cognizant of time and not have a super long video. So the first thing that we're going to have to do and focus on, the main goal today is that you can graph log functions, okay? And I'm also going to ask you to graph their inverses. And so when we talk about that, you may recall how to find an inverse and how to graph an inverse, but I'm going to show you that first before we kind of jump into the problems itself. So real quick review on graphing and writing inverses. So let's just take this function right here of y equals x squared. Everybody knows that that is a parabola. I'll even graph it, right? I'll just give you the basic shape of a parabola. It's x squared, okay? If I asked you to write the inverse of this function, all you do to write the inverse is you switch x and y and solve for y. You've done this before, but this is just a quick review. So if I was taking this equation here, y equals x squared, and I wanted you to write the inverse, what you would do is switch x and y, and you would solve for y. So I would switch out the x with the y on both parts, and then solve for y. I would square root, and so I'd get y equals plus or minus the square root of x. And this right here is the inverse function of x squared. And that should make sense, right? What's the inverse or opposite? Inverse means opposite. What's the opposite of x squared? Something square rooted. I'll put this, if you recall, the graph of a square root function looks like this, plus or minus, all right? The other thing you should remember about inverse functions is that they reflect over the line. And I'll put it here in my highlighter. Hope that shows up. Maybe not. I'll do it in pencil. Inverse functions of each other, when you graph them, they reflect over the line y equals x. This is the line y equals x, right? And so that's what your graph should look like. What we're going to do today is, yes, I'm going to ask you to graph logarithmic functions, but I'm also going to ask you to graph and write their inverses. And so you're going to kind of get some review worked into this assignment. So let's just jump right into it. Like I said, I'm going to go as quick as I can, but also want to make sure that I don't take up too much time. All right, so log functions, you have to graph this. I'm going to kind of give you some steps to follow over here as best I can. I know some of you like steps. The first thing, whenever you have a log function, the first thing you always want to do is you want to rewrite. You want to rewrite it in exponent form. Now, in lesson 5, the lesson before this, we learned how to convert this into exponent form. Now, I'm not saying inverse. We're not writing its inverse. We're going to just convert this. So a lot of times I would write this and put it backwards, because remember, what a log means. What does a logarithm mean? It means what power on 2 equals x. What power on 2 equals x. So we'd get something like this, right? Logarithms give you exponents. So all I did here was just take the original problem, I just put the y equals on the other side, and now I just rewrote it or converted it to exponent form. Now, next thing, we're just going to make a t-chart. We're going to make a t-chart, and you're going to pick values for y. So if you look at this, I have 2 to the y. So if you pick numbers for x, it's not going to work, right? You can't plug in numbers for x. You want to plug in numbers for y. So let's plug in a 0. If I plug in a 0 in for y, what's 2 to the 0 power? 1. So 1 would equal x. Okay? So 1, 0. So 1, 0. Let's plug in a 1. A 1 for y. 2 to the first is 2. So x equals 2. So 2, 1. 1, 2, and up 1. Okay, let's do one more. Let's plug in a 2 for y. 2 squared is 4, so 4 equals x. So 4, 2. Now let's go the other way. So I went 0, 1, and 2. Let's pick a negative, or excuse me, I went 0, 1, and 2 for my y values. Now I'm going to pick a negative 1. So if I pick a negative 1 for y, what's 2 to the negative 1? right? 2 to the negative 1, 2 to the negative 1 is going to equal 1/2. So I get 1/2. So when I go negative, or I go 1/2 on x, I get negative 1. And what's going to happen is if you pick a negative 2, I'm kind of running out of space here, but I'll put the negative 2 down here. If I pick a negative 2, I get 2 to the negative 2, which is 1/4. So I get 1/4 negative 2. So 1/4 negative 2. Well, what do you notice is going to happen? You're now going to get a graph that looks like this. You no longer have a horizontal asymptote. With logs, you have a vertical asymptote. Okay? And that vertical asymptote, the dotted line, would run right here. So log functions have vertical asymptotes. You need to know that. All right? Now I say, what's its inverse? So how do you do this? So part 4, for the inverse, here's what you want to do. You want to switch x and y and solve for y. Okay? Now, when you do that, I'm going to do this in red, you want to go with your exponential form. So you're going to take this now, and when we go to do the inverse, it's going to look like this. 2 to the x equals y. In other words, y equals 2 to the x. And if you look at that carefully, that should look very familiar to you, right? We know that as y equals 1 times 2 to the x, essentially. Well, let's graph that real quick. Let's graph this so you can see what I was talking about in the very first slide. So you got y equals 1 times 2 to the x. You're going to start at 1, right? And it's going to double. So here I'm going to go to 2, and then after 2 I'm going to go to 4, and I'm going to get this kind of graph. That's exponential growth. We just got done doing that. And what's really cool is when you see that the original function, which was the log, and its inverse, which is really this, and you graph them, they are reflected over the line of y equals x. Okay? Now, domain and range. I'm asking you for domain and range of the log function. All right? You should be able to answer the question, what is the domain and range for both of these, but let's talk and focus on blue. Now, domain. What does domain mean? Domain means your x values. Does your blue graph go to the right and to the left forever? No. It goes to the right forever, starting where? 0. So it's got to be, x has got to be greater than 0. Your range, is this blue graph going to go up and down forever? The answer is yes. It's going to track up and to the right and down forever, so your y values will be all real numbers. Okay? Now, I'm going to ask you to focus on, I'm going to come back to this in a minute, but we're going to focus on these two ordered pairs there, and we're going to try the next one on the next page. So what I would like you to do right now is go ahead and hit pause, and I would like you to try number 2. It's just like number 1, and see what you can come up with. Okay, so again, if we're following our steps, and you can always refer back to the steps here on the right-hand side of the first page, the first thing that we want to do is, if you go back to your steps, we want to rewrite this in exponent form. So again, if I was doing this problem, the first thing I would probably do is write it equal to y that way, because that's just easier for me. And then log means what power on 6 equals x. So what power on 6 equals x. And that's how we would rewrite that log function. Now again, that's not the inverse, that's just rewriting it into exponent form. We make our t-chart, go a little bit smaller here, and I'm going to pick a 0, and I'm going to get a 1. I'm going to pick a 1 for y, and I'm going to get a 6. Okay? I'm going to pick a 2 for y, and I'm going to get, if I pick a 2 for y, 6 squared would be 36. That's going to get massive real quick, right? If I go the other way, if I pick a negative 1, I'm going to get 6 to the negative 1. 6 to the negative 1 would be 1/6. So basically what I get is this, 1, 0, 6, 1. Going the other way, 2, basically 36 and 2. 36, 2, I'm going to be way off here, and it's just going to be up a little bit, right? It's going to be like somewhere over in here. And so this graph is going to look like this. It's the same shape. Log functions are the same shape as always. It's just, this one's a lot flatter. It's skinny, it gets skinny real quick. Inverse. What do we do with inverse, or how do we find the inverse? We take this and we're going to convert that, not convert it, excuse me, we're going to write the inverse by switching the x and the y, so that's going to become 6x equals y, and then I just rewrite it to be y equals 6 to the x. That is the inverse. To answer that question, this is the inverse function. Okay, if you had to graph that, again, what's really happening? That's the same thing as this. So that would be 1, and then it's basically multiples of 6 every single time. Okay, and so that graph would look like this. We'd start at 1, and then when we went 1 unit over, we'd be all the way up at 6. So it's this action right here. Again, getting really skinny, and you can see that these are, in fact, inverses of each other. So that's the inverse function. What's the domain and range of the log? Again, we're going to focus on the log only. So the blue, again, the domain right and left, that's going to be greater than 0, and its range is going to be all real numbers. Okay? All right. The one thing that I didn't mention here is I didn't put in my vertical asymptote for my log function. That's okay, but make sure you understand that that is there. Now, let's take a look at number 3. I bet you can tell me what's going to happen to this function when you have x plus 3 inside the parentheses. What have we done in the past? That's when you have something inside of the parentheses. I want you to just look ahead a little bit. Look at the number 4. When you get to number 4, which is, if you flip it over, minus 2 and then a plus 3 outside. I bet you can tell me what's going to happen to this log function. Okay? So what we're going to get into now on 3 are our translations, or our movements, right? And we're talking left and right and up and down. So look at number 4. The original function is y equals log base 4 of x. What's happening now? It's going to move to the right 2 and up 3, right? What's this one going to move? This one's going to move to the left 3, okay? Now, I want to kind of draw your attention to, and there's a lot of different ways to graph these, okay? Especially when you get into the translations, and I'm going to try to keep it as simple as I can for you. If you notice some patterns here, when we converted number 2, we got 1061. Look at the base, 6. 1061. Let's go back to number 1. When we converted it, right? Look at our points. 1021. Base was 2. So a common theme that you can write down, or a pattern that you'll start to see, I'll put it over here, a little pattern, is when you graph, like let's say I went log base 5 of x. Log base 5 of x. What are the 2 points that are always going to be consistent with log base 5 of x? 1, 0 and 5, 1. If I went y equals log base 7 of x, what are the 2 points that are always going to be consistent? 1, 0 and 7, 1. If I went y equals log base 10 of x, what are the 2 points that are always going to be consistent with that log? Be 1, 0 and 10, 1. So whatever the base is, you're going to have that point, okay? And the reason I'm telling you this is because it makes your life a lot easier when you have to do the translations. I'm just going to take these points that are always going to be consistent and just move those points to whatever direction the translation is telling me to move, okay? So let's apply that pattern, and let's look at this. So in my mind, when I look at this problem, the first thing I see is inside of the parentheses. That's going to tell me I'm going to move everything to the left 3 units. Now, when I look at this problem, here's what I'm thinking in my head. I'm thinking that's the parent function. That is the parent function. So what do I know the 2 points are? And again, you can rewrite this just like we did on the first 2. What would this be? This would be 3 to the y equals x. If you made your t-chart, what are the points going to be? Plug in a 0, you get a 1. You plug in a 1, you get a 3. So what you can do then is take these points of 1, 0, and I'm going to do it in pencil, 1, 0, but where does that point need to move? It needs to move to the left 3 units. 1, 2, 3. Okay? Now I'll erase it. 3, 1. 1, 2, 3. So over 3 and up 1. There's the original parent function point, but now I need to move that to the left 3. 1, 2, 3. Now the one thing that you need to know is, where is the vertical? Let me move this over here. Your vertical asymptote. Your vertical asymptote is always going to be the number inside of the parenthesis. So when we have like this x plus 3 here, your vertical asymptote is going to be at the vertical line of x equals negative 3. So it's going to be right here. 1, 2, 3. Just make sure I have it. Okay. And then those 2 pencil points I just have here, and boom, there's your graph. All right? And that's how you would graph number 3. Now, let's do domain and range right away so it's clear. Does this graph move to the right and to the left forever? No, it moves to the right forever, starting where? It's got to be bigger than 3, so x has got to be greater than negative 3, right? Because I went to the left 3. Every point went to the left 3. It shifted this whole parent function to the left 3, and there's my asymptote, my vertical asymptote, so it's got to be bigger than negative 3. Range up and down, all real numbers. Okay? Now, writing its inverse. This gets a little tricky. So if you take this original equation here and we change that into exponent form, what would that look like? Well, if you went log base 3 of x plus 3 and set it equal to y, you would have, if you're just converting this, again, I'm not writing the inverse, I'm converting this original question into exponential form, not its inverse, converting to exponential form. Log means what power on 3, so 3 to the y, equals the x plus 3. That right here, this right here, is the exponential form of this log function. If we want to write this log's inverse, we take the exponential version of it and we switch x and y and solve for y, which would look like this. 3x equals y plus 3, and solve that for y. Subtract 3 from both sides, right? And I get y equals, I'm just going to switch it around, 3 to the x minus 3. And that would be the inverse function of this log. Okay? If you wanted to graph this on here, you could. What's all that's really happening? That's the same thing as y equals 1 times 3 to the x with a minus 3. So that would look like this graphically. So this is review, right? This is a exponential function, so now it has a horizontal asymptote at negative 3, which would be right here, right? I'd be starting at 1, but then everything needs to move down 3, so I would move down 3. Let's see, where am I at here? I'm at 1, and I would move this down 3, so 1, 2, 3, and then I'd be tripling, so at 1 I'd be up at 3, but then that needs to move down 3, so 1, 2, 3, and my graph would look like this. I know that's not perfect, but again, look, you can see it's an inverse. It reflects over the line y equals x. Okay? All right, we're getting close to the end here. I know this is super long. So we're going to get to number 4 here. I want you to hit pause. I want you to try to graph it on your own and write its inverse. You do not have to graph the inverse, but write its inverse. Okay, so let's take a look at number 4. If I'm doing this problem, the first thing I'm doing is saying, what are my movements? This is going to move to the right 2 and up 3. What is the parent function? The parent function is y equals log base 4 to the x. Let's graph that lightly and then just move each point of the parent function to the right 2 and up 3. So if you know that if you're getting used to that pattern, right, it's always going to be 1, 0, and 4, 1, right? We did that on this page here, 1, 0, 5, 1, 1, 0, 7, 1, whatever the parent function is. So in pencil, I would just take my pencil. 1, 0 is here, but where is that point moving? That point's going to move to the right 2 and up 3. Right 2, up 3, 1, 2, 3. That's there, do. Okay? And then 4, 1, so here's 4, 1 right here, and where am I going to move that? Right 2 and up 3. 1, 2, 1, 2, 3. Okay? Now, where is your vertical asymptote? Where is your vertical asymptote going to be? that on paper? Well, it's whatever's inside the parentheses, so to the right 2. So my vertical asymptote would go right here. Okay? And my graph is going to look, and it's going to be, my vertical asymptote would be to the right, to the right 2. And so my graph is going to look like this. Okay? Awesome. Domain and range. Domain is going to be x has to be larger than 2. My range up and down, all real numbers. Now, inverse. This is kind of a tricky one here. So we're writing the inverse of the original equation, not the parent function. So if I convert this is kind of tricky here. What you would do is, if I'm converting this, you want to, anytime you have a +3 or any number outside of the parentheses, you would subtract that over. So I'd have y minus 3 equals log base 4 to x minus 2. And then let's convert this into exponent form. So what power on 4 gives me x minus 2? Y minus 3 is the power. So it'd be 4 to the y minus 3 equals x minus 2. This is not the inverse. This is the conversion to exponential form. Now we need to take this and write the inverse. So how do we do that? We switch x and y. 4x minus 3 equals y minus 2. And I'll solve that for y. I would just add 2 to the other side. So I get y equals, add 2, 4 to the x minus 3. That's the exponent. And then plus 2. And that would be your inverse right there. Okay? If you had to graph that, I would graph that as y equals 1 times 4 to the x minus 3 plus 2. And you could graph it that way. Okay? I know you have a 5th problem to do. Let's save that for class time, and we'll talk about what happens when you have a 2 that multiplies by your x, how that affects the graph, inverse, etc. All right? I know you may have some questions, and we can do a bunch of these until you start to feel comfortable, and I will definitely be looking forward to working with you in class on these. Thanks for your time.